All right, let's dive right into this explainer. Today, we're taking the standard Java curriculum and totally tossing out the dry textbook approach. Instead, we're using it as a dynamic blueprint. We're going to use this blueprint to build a real, functioning inventory management application completely from the ground up. If you've ever stared at a block of code and thought, okay, but how does this actually translate into the software running businesses all over the world? Well, you are absolutely in the right place. It's the ultimate question, isn't it? How exactly do you take lines of abstract code and transform them into a fully functioning store? We're going to answer that by taking those abstract concepts, like the syntax and rules of Java, and applying them directly to real-world tasks. We're not just going to talk about what a variable is, we are going to actually use it to put a product on a digital shelf. So here's our project blueprint for today. We'll kick things off with Welcome to Java Inventory, hit language basics and setup, and then tackle 3 core builds. Task 1, command line arguments. Task 2, decision-making logic. And finally, task 3, organizing with arrays. Let's get to laying that foundation.
Section 1. Welcome to Java Inventory. Every great structure needs solid materials, right? Let's check out the foundation of our store.
To actually start building, you've got to understand programming tokens. In the Java world, these are literally your raw materials. Think of them as your wood, your nails, and your concrete. You've got variables to hold your items, data types to define exactly what those items are, operators to do the heavy lifting with the math, and control structures to manage the entire flow of your store. Without these tokens, you can't build a thing.
Moving on to Section 2, language basics and setup. Before we start swinging those hammers, we really need to prep the workspace.
Setting up your Java architecture is basically securing your construction site. Nailing down the path and class path, that's just giving your computer the map to the site so it knows exactly where your tools are. After that, getting super familiar with Java keywords, basic data types, and operators are those absolutely crucial first steps for setting up a robust environment. Once you lock that architecture in, your workspace is officially open for business.
Section 3, Task 1, Command Line Arguments. Let's look at our first practical build and set up the front door to our store.
Check this out. By passing just 2 mandatory arguments through the command line, we can dynamically generate our store's welcome message. You see, instead of hard-coding the store's name directly into the program, which is pretty rigid, we provide ABC and Mumbai right at the exact moment we run the code. The Java program snags those command line arguments and instantly customizes the whole user experience.
Here's the real takeaway, though. Mastering these inputs isn't just a neat trick to print some text on a screen. It is the very first step in creating functional, adaptable inventory apps. It proves your code can actually listen to the outside world and respond on the fly.
Section 4, Task 2, decision-making logic. Our store is open, but a store can't just be a static room. We need to give our app a brain so it can monitor its own stock.
To pull that off, we equip the app with a killer toolkit of flow control statements. We're talking about if-else statements, switch cases, and while loops. This gives our application the power to react to changing real-time information. Instead of just holding data like a digital filing cabinet, the program can now look at that data, ask a specific question about it, and decide exactly what action to take next. We can take those conditionals and tackle a real business problem head-on. Imagine using a simple if statement to evaluate stock quantities. If the system reads a 0, boom, it triggers an out-of-stock alert. If it's dipping below 10, it warns us with low stock. And if it's 10 or more, we get an available stock green light. So why should you care about this? Well, automating these alerts is an absolute game changer for operational decision-making. With just a handful of lines of flow control logic, you're making sure a store manager always knows exactly when supplies are running low. You're completely eliminating the need for someone to manually go count items on a physical shelf every single hour. All right, Section 5, Task 3, Organizing with Arrays. For our final build, we're getting a major upgrade. We're moving from managing single items to handling an entire warehouse of goods. To handle that kind of volume efficiently, we bring in arrays. Think of arrays as your digital shelving units. They can exist in one dimension, like a single long row of items, or 2 dimensions, which is more like an entire grid of aisles and shelves. Creating 50 different variables for 50 products would be a total nightmare. But arrays? They let us group and store quantities of multiple products securely and neatly in one single spot.
When we load up an array with the specific stock quantities of, say, 5 different products, we can instantly organize the entire inventory. The array keeps all this related data tightly bundled, which makes it incredibly easy for our Java program to read through it, update it, or analyze it on the fly.
And because everything is perfectly grouped together, the math becomes an absolute breeze. The program can just loop right through those digital shelves and instantly calculate critical metrics like summing everything up to find a total stock of 500 items.
Or, we could just as easily tell the program to grab that total, divide it by the array's length, and find the average stock per product. In this case, that gives us an average of 100.
Doing this isn't just some abstract math exercise. This is exactly how developers drive efficient resource management and high-level operational planning. It transforms a bunch of raw numbers into actual, actionable business intelligence.
Looking back at our blueprint, it's pretty amazing what we've put together. We used foundational tokens, like variables, to pour the concrete base. We brought in intelligent flow control so our store could make vital stock decisions. And finally, we rolled out organized arrays to manage our warehouse data efficiently, put it all together, and we built a working operational tool.
You've seen firsthand how abstract code transforms into a tangible, working solution. Now that you've got these core Java fundamentals locked securely in your tool belt, what are you going to build next?